we have a test review. I'm going to go through it pretty quickly. If you have any questions, just let me know. Alright, so number one, it says to state the zero factor property, which says something like this. If a times b is 0, then either a is 0 or b is 0. And this is the primary driving theorem behind factoring. This is why factoring works. And speaking of that, so looking at number 2, we're trying to rewrite x squared plus x minus 30 as a product of two things. So I need to think of two things and multiply to give me negative 30 and add to give me positive 1. 6 and negative 5. X plus 6 times x minus 5. Those multiply to give me negative 30, add to give me positive 1. And because of the zero factor property, since it said equal to 0, I know that either x plus 6 or x minus 5 equals 0. So that means that x equals negative 6 or 5. Okay, moving on to number 3, the same deal. I'm trying to think of two things and multiply to give me negative 28, add to give me negative 3. I think negative 7 and 4 will do it. And so I get x is 7 and negative 4. Alright, now remember this is because I'm taking, for example, x minus 7 to be 0 and x plus 4 to be 0. These are two linear equations. So I get x equals positive 7 and negative 4. That's how that works. And it only works because of the zero factor property. Okay, for number 4, we have x squared plus 6x minus 10 equals 0. We're going to solve this by completing the square. You can start off by trying to factor it, but you'll realize you can't find two things and multiply to give you negative 10 and add to give you positive 6. So we're going to move on to completing the square. So the first thing I need to do is move the 10 over. So I'm going to say this, plus blank equals 10 plus blank. Now I got to figure out how to fill in the blank. I do that by taking the linear term, dividing it by 2, squaring that, and adding that back in on both sides. Now that'll allow me to factor the x squared plus 6x plus 9 as a perfect square. What multiplies to give you 9, add to give you 6, 3 and 3. And by the way, it will always be this term. And from there we can solve by taking the square root. Don't forget your plus minus when you're taking the square root of both sides. So I end up with x equals negative 3 plus or minus the square root of 19. Alright, for number 5, we're trying to solve this thing by the quadratic formula. So you got to remember what the quadratic formula says. And yes, you do have to memorize that. And so plugging in these values, I get something like this. That's negative b, which is positive 5, plus or minus the square root of b squared, that's negative 5 quantity squared, minus 4 times a, which is 2, times c, negative 1, all over 2 times 2. Now this can simplify a little bit. We get 5 plus or minus the square root of 25 plus 8. So we get 5 plus or minus the square root of 33 over 4. And square root of 33 doesn't simplify any, right? Because 33 is just 3 and 11, and so that square root doesn't simplify anymore. That is my solution. Okay, that covers all the techniques of solving quadratic equations, but now we're going to move on to polynomial equations, and these are ones that we can factor. So start off with x to the fourth minus 81 equals 0. And the trick to this one is to recognize that x to the fourth is the same thing as x squared squared. And of course 81 is 9 squared. And so I'm using my special binomial formula that says a squared minus b squared is the same thing as a minus b times a plus b. So letting x squared be a and 9 be b, I have x squared minus 9 times x squared plus 9 equals 0. Now I'm going to solve these both like this. I'm going to move the 9 over, and then I'm using the square root property. So I'm going to take the square root of both sides. So I get plus or minus the square root of 9, which is 3. For x squared plus 9 equals 0, move the 9 over, and when I take the square root of both sides, I have plus or minus the square root of a negative 9. So remember that's going to be the square root of 9 times the square root of negative 1, which is I. And so there I have my four solutions, plus or minus 3 and plus or minus 3i. Alright, for number 7, the trick to this is to factor by grouping. And this should say equals 0 up here. Yeah, that's missing. Okay, so now in the first two terms, I can factor out an x squared. In the second two terms, I can take out a negative 4. And when I do that, I'm left with an x plus 11. If you're not sure about that, distribute the negative 4 back in. And you should get negative 4x minus 44. Alright, now I have two terms with a common factor. The common factor is the x plus 11. So I can take out the x plus 11, And when I do that, out of my first term, I'm left with an x squared. Out of my second term, I'm left with a negative 4. So there I have factored it, x plus 11 times x squared minus 4. And actually, I can factor this a little bit more because I know x squared minus 4, using my a squared minus b squared, the difference of squares formula, is going to be x minus 2 times x plus 2 set equal to 0. So now I have three solutions. One is negative 1, positive 2, and negative 2. And there are my three solutions. I hope those make sense. We're just factoring just like we did with quadratics, just maybe an extra step or two. Okay, now moving on to rational expressions. In number 8 and 9, I want to simplify the following rational expressions. Okay, so for number 8, it's a division problem. So what you need to do is two things. We need to factor everything. Let's try to do that first. Two things to multiply to give me negative 28, add to give me negative 3. How about negative 7 and positive 4? In the denominator, I should get x minus 5 times x plus 4. On the other side, x squared minus 49 is the difference of squares. And in the denominator, two things to multiply to give me negative 15, add to give me negative 2. How about x minus 5 and x plus 3? Okay, now the next thing I need to do is convert division into a multiplication question, and the way I do that is by remembering dividing by a fraction is the same as multiplying by its reciprocal. I have x minus 7 times x plus 4 divided by x minus 5 times x plus 4 times the reciprocal of what I had. So that's x minus 5 times x plus 3 over x minus 7 times x plus 7. And now I can see some stuff's going to cancel out. My x plus 4's canceled out, x minus 7's, and x minus 5's as well. So at the end of the day, this thing simplifies down to x plus 3 times x plus 7, and there's my solutions. Okay, for number 9, I'm trying to add some fractions together. I need to, well, let's factor this and realize that x squared minus 4 is the same as x plus 2 times x minus 2. So if I'm going to add fractions together, I have to get a common denominator. And I can see here my common denominator is just going to be all my common parts put together. So that's going to be an x plus 2 times x minus 2. So I have three expressions with that common denominator. And actually the third expression already had the common denominator, so there's nothing to do. The first one, to get from here to here, I have to think what was missing. And I can see that what was missing was x plus 2. So I'm going to multiply x plus 2 in the numerator and the denominator, which means my numerator here is x plus 2 times x minus 1. For the second one, I have to recognize that what was missing was an x minus 2. So I'm going to multiply it in the numerator and in the denominator, and I don't have a lot of room here. So this looks like x plus 4 times x minus 2 like that. Now that I have a common denominator, I can bring these together. I need to FOIL it out and add them up. So let's see what happens. Okay, so I FOILed out all my numerators, so that's x squared plus 2x minus x becomes plus x minus 2. And then in the second numerator I have x squared plus 4x minus 2x, which is positive 2x, minus 8. And then lastly, I didn't have to FOIL anything. Now another thing I recommend is to go ahead and distribute my negative here. So I'm going to make this a positive and flip the signs of everything up here. That way I just don't forget. And now finally I can add everything together. So I have x squared plus a negative x squared. So I have my x squared subtract out. My x to the first powers, I have x minus 2x plus x. So that's x minus 2x plus x. So those actually zero out as well. That doesn't always happen. And then lastly, my constant terms, I have negative 2 plus 8, so that's 6, minus 3. I end up with 3 over x plus 2 times x minus 2. And there it is. There is the reduced form of what we were dealing with originally. That is to say, this expression equals that. Okay, so moving on to number 10, it's a similar idea. You gotta think about what your common denominator would be and multiply that on both sides of the equation so that you can cancel out all the denominators. So what I mean by that here is I'm going to multiply both sides by this 6 minus z, but also by z plus 6. Okay, and if I do that to one side of the equation, I have to do it to the other. So what happens is, as I'm distributing this across, when I distribute across my first term, the z plus 6's cancel out. So I end up with 6 minus z times z. When I distribute it across the second expression, the 6 minus z's cancel out. I'm left with a z plus 6 times a z minus 1. And on the right side of the equation, the 6 minus z's cancel out. And I'm left with a z times a z plus 6. Now I have a quadratic equation, and we can solve it pretty quickly. So I'm going to clean it up, and then we'll see. So first of all, cleaning it up, I have 6z minus z squared plus z squared plus 5z minus 6 equals z squared plus 6z. Moving everything over to one side of the equation, you should end up with z squared minus 5z plus 6. Okay, and now that can factor, because the two things that multiply to give me positive 6, add to give me negative 5. How about negative 3 and negative 2? So that means z equals 3 and 2, and there is my solution. And that is valid because notice if I had gotten 6 or negative 6, that would have been a problem, right? Z couldn't have been 6 or negative 6. That's not an issue here because we got 3 and 2. So we're good. All right, now moving to 11. Hot water tap can fill a sink in 4 minutes. If the cold water tap's turned on as well, the sink fills in 1 minute. How long would it take for the cold water tap to fill the sink alone? Okay, so this is a work rate problem. And remember that work rates are reciprocal. So for example, hot water tap can fill a sink in 4 minutes. That means for every 1 unit of time, you've done 1/4 of the job. Now, if you add that to the cold water tap, which we don't know, that'd be 1 over x, and then it would only take 1 out of 1 unit of time to fill up the sink. And now we've got to solve for x, and that's how long it would take for the cold to fill up the sink without the hot water. Okay, so this is a rational equation, and it's actually not a bad one here, because we can say then that 1 over x equals 1 minus a fourth, which means that 1 over x equals 3/4. So x then is 4/3 minutes. Okay, so in time, that means like 1 1/3 minute, or 1 minute 20 seconds, right? Okay, but we'll accept 4/3 minutes if you want. Number 12, we have square root of 4 minus y. Minus y equals 2. You need to isolate the radical. And now to get rid of the radical, we square both sides. So when I square the square root, I get just 4 minus y, and then I have y plus 2 squared, which I'm going to go ahead and FOIL out. Now if you needed help with that, what I did was I said y plus 2 squared, which is y squared, plus 2y plus 2y plus 4. Okay, so that's how I got that. All right, now also I need to make a note here. Anytime that happens, anytime we square both sides, we have to check our solutions. So we will have to check here. But now we have a quadratic equation. So I get y squared plus 5y equals 0. So here we can factor by greatest common factor. So I get y equals 0, y equals negative 5. And now I have to check my solutions. So if I plug in 0 into the original equation, I get the square root of 4 minus 0 equals 2. That does check, right? That's 2 equals 2. That checks. If I plug in negative 5, I get the square root of 4 minus a negative 5. Okay, so that would be, and then I have plus 5 equals 2. Well, 4 minus negative 5, that's the square root of 9. So I get 3 plus 5 equals 2. That doesn't work. Okay, so the negative 5 doesn't check. My solution then is y equals 0. So remember, when you square both sides, you have to check your solutions. And we'll do that again here in number 13. So this time I'm going to square both sides. And when I do, I'm going to actually have to FOIL the left-hand side of my equation. So when I do that, I end up with the square root of 3 minus 3t quantity squared. The outside terms, minus 3 square root of 3 minus 3t. The inside terms, which is minus 3 square root of 3 minus 3t. And then my last terms, which would be a plus 9. On the other side of my equation, I just get 3t plus 2. Okay, this is not pretty, but it'll work out. We're going to have to square both sides again. Let me clean it up a little bit first. So I end up with negative 6 square root of 3 minus 3t equals 6t minus 10. And let's make a note, we squared it, so we're going to have to check our solutions. Okay, I'm going to go ahead and divide everything by 2 because I noticed everything is even here, just to make my numbers a little easier to work with. And now I'm going to square both sides again. So I get 9, 3 minus 3t equals, when I FOIL this side, okay, and I have a quadratic equation. So distributing my 9 and then get everything over on one side of the equation, I should end up with 9t squared minus 3t minus 2 equals 0. Alright, now, how do I factor that? This is a good review. I'm going to multiply those two together, get negative 18. Break that up into two things, and multiply to give me negative 18, add to give me negative 3. So you could try 2 and negative 9, that doesn't work. You could try some other things. Eventually, negative 6 and 3 work. Okay, so what I'm going to do then, I'm going to replace my negative 3t with minus 6t plus 3t minus 2. And now I can factor by grouping. So on my first group, I'm going to take out a 3t. And when I do, I'm left with a 3t minus 2. Out of the second group, I can't take out anything other than 1. But notice that still did the trick. I have two factors, and out of those two factors, I have a common factor of 3t minus 2. And then I end up with 3t minus 2 times 3t plus 1. Okay, now setting each of those equal to 0. Out of my first one, I end up with t equals 2/3. Out of the second one, I end up with negative 1/3. Okay, and we need to check. So if I check 2/3 back into the original, which is right here, I have, well, let's just think about it. If I plug in 2/3 in for t there, 2/3 times 3, that ends up being 2. So I have 3 minus 2, square root of that is 1. So this all becomes 1 minus 3. I end up with a negative 2. If I plug in 2/3 onto this side, that becomes 2/3 times 3 is 2. 2 plus 2 is 4. I get a positive 2. That does not work. So 2/3 does not check. If I plug in negative 1/3 in for t there, 3 times negative 1/3 is negative 1. So 3 minus negative 1 becomes 4. That's the square root of 4 is 2. Minus 3, I get negative 1. On the other side of the equation, if I plug in negative 1/3, I get 3 times negative 1/3 is negative 1 plus 2, that becomes 1, so the square root of that becomes positive 1. So negative 1/3 doesn't check either. Okay, so actually here I have no solutions. There is no value that makes that a true statement. Okay, now we had to go through a lot here. The hard part was actually just having to square both sides 2 times. After that, we had to factor a quadratic. That's not an easy one. And then we had to check our solutions, and we got something kind of disappointing because neither one of them checked out. But nevertheless, that's how it works. Okay, now let's move on to number 14, finding distance. Well, we just have to remember the distance formula, which says the difference of the x's squared plus the difference of the y's squared. And so this is just a matter of plugging in our points appropriately. So negative 7 minus 13 gives me negative 20. So I get 20 squared, which is 400. And then negative 2 plus 14 is 12. 12 squared is 144. So I end up with a distance of 544. Now playing with my calculator a little bit, I realized that is the same thing as 16 times 34. And so that can give me 4 square root of 34. All right, so there's my distance between my 2 points. Okay, going on to 15, we got to find the midpoint. The midpoint is just the average of my x coordinates and the average of my y coordinates. So that would give me then 13 minus 7 is 6. 6 over 2 is 3. Negative 14 minus 2 is negative 16 over 2. It gives me negative 8. And there it is. For number 16, finding the x and y intercepts of this line. For the x-intercept, we let y be 0. And so then I get 4x minus 0 equals 30, or x equals 30 over 4, or 15 halves. So there's your x coordinate. For my y coordinate, or my y-intercept, I let x be 0. And so when I plug in 0 for x, I get 0 minus 5y equals 30, or y equals negative 6. And there's my y-intercept. If you wanted to write these as points, your x-intercept is 15 halves over, comma 0, and your y-intercept is 0 negative 6. Alright, so for number 7, we want to find the slope of the line that passes through those points. So remember the slope formula is the difference in the y's over the difference of the x's. So that means then that m equals negative 2 minus the negative 3 over negative 1 minus 9. So that would be negative 2 plus 3, which is 1, over negative 10. And there's my slope. Sometimes you might write this as negative 1/10. Same deal though. Okay, and does it matter which one is your x1, y1, x2, y2? It does not, as long as you're consistent. So I said this minus the negative 3, which forced me then to say negative 1 minus 9. Otherwise, I'd have gotten positive 1/10, and that's not correct. Okay, number 8, it says find the equation of the horizontal line with a y-intercept negative 4. This is an easy question. I remember horizontal lines are always y equals a constant. So if I have a y-intercept, at negative 4, that means I must be at the constant y equals negative 4. You could graph that like this. Here's negative 4. Add a y-intercept there, so I pass through there. That's my line. Vertical lines, remember, are x equals a constant. Okay, so remember that. If I had an x-intercept of 3 or something, that would be a vertical line, x equals 3, that passes through there. Alright, number 19. Find the equation line passing through 3, negative 5 with a slope of 7. We're using point slope form. Y minus y1 equals m times x minus x1. They gave me a slope. So I say y minus a negative 5 equals 7 times x minus 3. Or once I simplify that, I get y equals 7x minus 27. Okay, for number 20, we have to do that again, except this time we have to find the slope as well. So the slope is pretty easy, right? It's the difference of the y's. So I'm going to say 2 minus 1, which forces me to say negative 1 minus 3. So that gives me negative 1/4. There's my slope. Now I can pick any point I want. It doesn't really matter. I'm going to say y minus 2 equals negative 4th x minus a negative 1. So that becomes x plus 1. And so cleaning this up, I get negative 4th x minus 1/4 plus 2. That's the same thing as saying negative 1/4 x. Okay, the 2 is the same thing as 8/4, right? So that's going to be plus 7/4, and there it is. There's my line. Number 21 says find the equation line parallel to negative 4x plus 8 and passes through the point 3, negative 5. I just have to remember that my slope, since it's parallel, my slope is going to be that negative 4. So then my line then is going to be using the same formula. Y minus a negative 5 equals negative 4 times x minus 3. So that's going to be y equals negative 4x plus 12, bringing the 5 over. So I end up with negative 4x plus 7. There's my line. Okay, number 22, similar to that, but this time we have a perpendicular line. I know that my slope's going to be positive 8/11, because remember, perpendicular lines have reciprocal slopes. So then I have y minus a negative 2, which is y plus 2, 8/11, which is normally ugly. Here, though, I think they made it easy on us, right? Because of x minus 11. So when I distribute, I get 8/11x. Well, 8/11 times 11 becomes minus 8, and then bringing the 2 over. So I end up with y equals 8/11 x minus 10. And there's my line. So number 23, we're going to solve the linear inequality 3x minus 6y greater than 9 by graphing. Okay, so all we have to do here is graph the line. All right, so if I pick my x-intercept, for example, x-intercept, I'll let y be 0. So that means x is 3. So I have an x-intercept at 3. If I try to find my y-intercept, that means I'll let x be 0. So if x is 0, I get negative 6y equals 9, or y equals negative 9/6, which is negative 3/2, which is negative 1/2. So there's my y-intercept. I'm going to connect these two, but since it's strictly greater than, I want a dotted line. And now I got to figure out which side of this plane to shade in. And so I need to pick a test point. I'm going to pick the test point 0, 0. If I plug in 0, 0, I get 3 times 0 minus 6 times 0. And I'm saying that's greater than 9. And it's not, right? So 0, 0 is not in my shaded region. My shaded region is actually on this side, like that. And again, a detail. It's a dotted line because it's strictly greater than, right? There's no less than or equal to, so it's not solid. And the test point helps you figure out what side of this you need a shade. Okay, number 24, we have absolute value inequality. Absolute value of x minus 6 is less than or equal to 1. So the way I drop absolute value is if it's less than, that means that I have to be less than or equal to 1, but I also have to be greater than or equal to negative 1. And so remember, a less than or equal to turns into an and situation. If it was greater than, it would turn into an or situation. So here I have x is less than or equal to, adding 6 to both sides gives me 7. On the other hand, it's greater than or equal to, adding 6 to both sides, 5. And I can graph both of these. These are vertical lines. My axis doesn't go up far enough. So let's add 6 and 7 on here. For 7, a vertical line like this, and it is solid because it's or equal to. For 5, there's my other one. Okay, now notice it says less than 7, so that's shading this part. That's the less than 7. But at the same time, it's got to be greater than 5. So it's actually this middle region here. It's got to satisfy both of those. And so that's the region you get right through here. And that's how it goes. Now if it had been something like this, then it becomes x minus 6 is greater than or equal to 1, or x minus 6 is less than or equal to negative 1. And so in that case, that would be out here and out there, like that. And that's what the or situation turns into. Our situation though was the and. This is what we want, the yellow. All right, now lastly, we want to find the equation of the circle with a center negative 310 and a radius 7. Okay, so this is all about just remembering the equation of a circle, which says x minus h, in this case, minus a negative 3 squared plus y minus k, in this case, y minus 10, equals radius squared. So I have x plus 3 quantity squared times y minus 10 squared equals 49. And there it is. There's the equation of my circle. That's it. That's all you have to do. Alright, so we've gone over 25 questions fairly quickly. I hope these make sense. If you have any questions on these, I'd be glad to help. And thank you for watching.